this video, we're going to look at ionic bonding. So when atoms form ions by gaining or losing electrons, oppositely charged ions formed are held together by electrostatic forces of attraction. These electrostatic forces of attraction are often called ionic bonds. So it's the attraction between the positive and negative ions formed when atoms lose or gain electrons. So how can we determine the charge of an ion from the periodic table? Well, group 1 elements, the atoms of these elements all have one electron in their outer shell. So when they lose this electron to become stable, they're losing one negative particle. So overall, they're left with a charge of positive 1. Similarly, in group 2, when these atoms lose the 2 electrons in their outer shell, they form ions with a charge of positive 2. In group 6, they have 6 electrons in their outer shell, so they need to gain 2 electrons to have a full outer shell and become stable, so they will have a charge of -2. And similarly, in group 7, these have 7 electrons in the outer shell, so they need to gain 1 to have a full outer shell and be stable, so they will have a charge of -1. And in group 8, or group 0, the atoms of these elements already have full valence shells, so they do not lose or gain electrons to form ions. So now we're going to look at drawing dot and cross diagrams of ionic compounds, starting with lithium fluoride. Now lithium is in group 1 of the periodic table. It has 3 electrons, which means it has 2 in the first shell and 1 in its outer shell. Fluorine is in group 7. Now fluorine has an atomic number of 9 and a mass number of 19, which means it has 9 protons and so 9 electrons if it's neutral. So in the first shell, fluorine is also going to have 2 electrons, and then in the next shell, it's going to have 7. And these add together to make a total of 9. So lithium has 1 electron in its outer shell that it needs to lose, and fluorine has an outer shell that's missing 1 electron for fluorine to be stable. So the electron in fluorine's outer shell will be lost and transferred to fluorine. So if we draw this now as the 2 ions, lithium now only has 1 shell with 2 electrons, and it's an ion. Don't forget the square brackets, and we're going to show the charge of positive. And then fluorine has 2 shells, and we're going to use dots to show the electrons on fluorine. And then the electron that's come from lithium, we're going to draw with an X to show that it originated from lithium. And then we draw the brackets and the charge. Now fluorine gains an electron, so it's going to have a charge of -. And this is how we can draw the ionic bond in lithium fluoride. As you can see, the charges are the same amount but opposite, so they cancel each other out, which means that the chemical formula for the compound lithium fluoride would be LiF. Our second example is going to be magnesium oxide. So magnesium has 12 electrons, 2 in the first shell, 8 in the next shell, and 2 in its valence shell. And then oxygen has 8 electrons, 2 in its first shell, and 6 in its outer shell. So as you can see, magnesium has 2 electrons that it needs to lose to have a full outer shell and be stable, and oxygen needs to gain 2 electrons. So these 2 electrons can be lost by magnesium and gained by oxygen. So if we draw this using our dot and cross diagram, we're going to draw the ion of magnesium. It only has 2 shells now. And it has a charge of 2 plus because it's lost 2 electrons. And then we're going to draw the oxygen ion, or the oxide ion. And we're going to use crosses to represent the electrons that came from magnesium. And this will have a charge, this oxide ion will have a charge of 2 minus because it's gained 2 negative electrons. Now, as you can see, the charges are equal and opposite, so they cancel each other out, which means that the chemical formula of the ionic compound magnesium oxide is MgO. The last example that we're going to look at is potassium sulfide. Now, potassium has an atomic number of 19 and a mass number of 39, and sulfur has an atomic number of 16 and a mass number of 32. So if we draw the potassium atom, in its first shell it's going to have 2 electrons. In its next shell it's going to have 8. This gives it a total of 10. In its next shell it's going to have 8. This gives it a total of 18. And in its final valence shell it's going to have 1. Then if we draw sulfur, it has 2 electrons in its first shell or inner shell. Then it has 8 electrons in its second shell. This gives it a total of 10. And then the remaining 6 electrons in its valence shell or outer shell. So as you can see, the potassium needs to lose the single valence electron, and sulfur needs to gain 2 electrons. So one potassium atom can lose its outer electron, and sulfur can gain 1 electron from one potassium atom, but therefore we need another potassium atom. So from another potassium atom, it can lose its outer shell electron and fill the remaining space in sulfur. So another potassium atom will lose its valence electron to fill this gap in sulfur. So 2 potassium atoms each lose their single outer electron. The sulfur atom will gain the 2 electrons to fill its outer shell. So if we draw this using a dot and cross diagram, I'm only going to draw the outer shells. Potassium will now have a full outer shell. Now it's lost 1 electron, so it will be positively charged by 1. Sulfur, its outer shell, is going to be full. And I'm going to use crosses to draw the 2 electrons gained from 2 potassium atoms. And because it's gained 2 electrons, it's going to have a charge of 2 minus. And I'm going to draw the other potassium ion. Now, as you can see, we have an overall 2 positive charges and 2 negative charges. So these are equal and opposite and cancel each other out. Therefore, the chemical formula of the ionic compound potassium sulfide is K2S. So this shows a ratio of 2 potassium ions for every 1 sulfide ion. Okay, now I want you to pause the video here and try to draw the dot and cross diagrams for the ionic compounds sodium chloride, calcium fluoride, and lithium oxide. So this is what you should have. One important thing to note here is that I've only shown the outer electron shells for each of these ions. I have not drawn any of the inner shells. Sodium loses its outer electron to become positive, and chlorine gains the electron from sodium to become minus. Calcium loses its 2 outer electrons, and fluorine gains 1 electron from calcium, and then another fluorine atom gains another electron from calcium to form 2 fluoride ions. And as you can see, the charges are overall the same and opposite, so we need 2 fluoride ions to cancel out the 2 positive charges on calcium. Then with the final one, each lithium atom loses its outer shell electron to form 2 lithium ions, each with a positive charge, and oxygen gains 1 electron from each of the 2 sodium atoms, so it gains 2 electrons in total to have a charge of 2 minus. Popular exam questions will ask you to describe how ionic bonds are formed between atoms. So here's an example. Describe how sodium chloride is formed from its atoms. So these are sometimes worth 3 marks. The first mark could be for saying that the sodium atom loses 1 electron to form Na+, which is the sodium ion. The second mark could be for saying that the chlorine atom gains 1 electron to form a chloride ion. And then the third mark could be for saying that oppositely charged ions attract. And so this is how they're held together. Remember that these forces of attraction are called electrostatic forces of attraction in ionic bonding.